Above ground, the Chihuahuan Desert of West Texas hums with the gentle lull of swaying creosote bushes and buzzing carpenter bees. But hidden beneath the sands lay an entirely different story. Here, vast networks of plastic and steel pipelines subtly cut across the underground landscape. These tubular behemoths rush with the sound of highly pressurized fossil fuels, sending millions of gallons of liquefied natural gas to ports and cities far away. Situated at the center of these crude oil arteries and veins, we find the heart of the Permian Basin. For those unfamiliar, the Permian Basin formed about 299 to 251 million years ago, around the time of the Permian period of geologic time. Essentially just a dip or depression in the earth, it was this basin's formation that turned into a hotspot of oil and natural gas production. Dominated by a sedimentary rock called shale, the Permian Basin developed various rock traps for the accumulation of plant and animal remains. Over time, immense pressure and heat from being underground transformed the dead plants and animals into oil and gas. Since this oil was trapped between rock layers, it became embedded within the shale rock to create oil-bearing shale. This type of oil source is otherwise known as tight oil and requires the use of hydraulic fracking drilling techniques that use large amounts of water to blast away shale rocks for excavation. And we mean a lot of water is used in fracking. We mean around 1.5 to 16 million gallons of water needed just for a single well. This problem is exacerbated by the fact that fracking is the most popular form of oil drilling in the Permian Basin, as it is really the only way that oil-bearing shale rocks can be separated from surrounding rocks. After extraction at wellheads, the filthy mixture of oil-bearing shale and water is sent through gathering pipes to a processing facility. In the Permian Basin, there are a total of 15 processing facilities that these rocks can end up. At the facilities, the oil-bearing shale rocks are heated to around 842 to 932 degrees Fahrenheit without oxygen to release natural gas, condensable oil, and other solid residues. Since this video focuses on natural gas from the Permian Basin, we will not be looking at how oil and other solid residues make their way to markets. Once natural gas is released from rocks at the processing facility, it undergoes a stage of liquefaction at negative 260 degrees Fahrenheit. This is done to reduce the volume of the substance, as liquid natural gas is only 1/600th the volume of its gaseous state. Thus, when in long-term storage or transportation, natural gas will usually be found in a liquefied form. Now that we've gone from a waxy shale rock to a colorless natural gas liquid, we can begin the long journey away from the Permian Basin and to the international markets. Using data from the Global Gas Infrastructure Tracker, we've mapped out the course of all 27 gas pipelines in the Permian Basin. To begin, we'll look at pipelines that traverse near El Paso, including the ones used to fuel pipelines in Mexico. First on this list is a conveniently named El Paso gas pipeline. This line comes closest to El Paso, passing directly under Woodrow Bean Trans Mountain Drive as well as the town of Canutillo. From there it supplies natural gas to New Mexico, Arizona, California, Colorado, and northern/central Texas. The next nearest pipelines are found in bunches that cross through the border towns of San Isidro in Mexico and San Elizario in the United States. Here we find the Comanche Trail Pipeline, the Roadrunner Pipeline, and the Waha-San Elizario Gas Pipeline. At the border, these lines connect to the San Isidro-Samalayuca Gas Pipeline, the Tarahumara Gas Pipeline, the Samalayuca-Sasabe Gas Pipeline, and the Sistema Nacional de Gasoductos, otherwise known as SNG. Further to the south, near Big Bend Ranch National Park, the Trans-Pecos Gas Pipeline crosses the border to connect to the Ojinaga-El Encino Gas Pipeline in Ojinaga, Mexico. There are plans to build a Waha to Presidio gas pipeline along the same route as the Trans-Pecos line, but since no construction or development has been made in the past 4 years, the project is considered cancelled. With the pipelines near El Paso and Mexico covered, we will move back eastward towards the Permian Basin again. These next gas pipes are the ones used for internal transportation of liquefied natural gas within the basins themselves. The largest of these internal gas pipelines is the Agua Blanca pipeline, followed by the Red Bluff Express pipeline. and the Delaware Basin gas pipeline, which is named after the specific basin within the Permian called the Delaware Basin. This is followed by the Gulf Coast southbound pipeline, and there is a fifth internal pipeline that has been proposed called the Delaware Link gas pipeline, but construction has yet to begin. Aside from transporting natural gas within the basins, there are also pipelines that move fossil fuels across state lines of the United States. Similarly to the already mentioned El Paso gas pipeline, the Transwestern gas pipeline also supplies the states of New Mexico, Colorado, Arizona, California, and northern Texas. Next, there is the Northern Natural Gas Pipeline that crosses from Texas to Oklahoma, Kansas, Nebraska, Iowa, Wisconsin, and up to the Great Lakes in Minnesota for sea transportation to Canada. In addition, there is the Natural Gas Pipeline Company of America, which moves from Texas to New Mexico, Oklahoma, Kansas, Missouri, Iowa, Illinois, then through Missouri again, Arkansas, then back to Texas. The next three pipelines pass only to New Mexico and include the Carlsbad Gateway Pipeline, the Double E Pipeline Project, and the proposed Steady Eddy line that has yet to begin construction. The last set of pipelines we'll cover are the ones that primarily fuel the state of Texas, but also reach liquefied natural gas, otherwise called LNG terminals, along the Texan coast. It is at these LNG terminals that most of the natural gas from the Permian Basin is loaded onto carrier ships and sold to foreign countries around the world. To begin, we'll look at the pipelines that reach the Corpus Christi LNG terminals. There is the Whistler Pipeline that reaches up to Midland, but mainly follows a southern route towards Corpus. Then we have the Gulf Coast Express Pipeline, which follows a path identical to the Whistler line. And then there is the Pecos Trail Pipeline, whose construction has been delayed for at least 2 years now, making it a shelved, unoperational pipeline. Next are the pipelines that arrive at the Houston and Galveston LNG terminals. These include the Texas Intrastate System Gas Pipeline, which splits into 3 lines crossing the cities of Austin, San Angelo, and Denton. Then there is the Oasis Gas Pipeline that moves along a more southern route to Houston. Next is the Permian Highway Pipeline, which ends just short of Houston but connects with the already mentioned Natural Gas Pipeline Company of America to reach LNG terminals in Galveston Bay. The Atmos Pipeline of Texas is by far the biggest in the state by length span and covers Texan cities from Wichita Falls down to Houston. The Bluebonnet Market Express Pipeline and Permian Katy Pipeline also arrive at Houston, but construction on these 2 lines has halted for 2 years, making them shelved and unoperational. The last pipeline on our list is the Permian Global Access Pipeline that ends just north of Lake Charles, Louisiana, but its construction has been delayed for 2 years, making it a shelved project. It is important to mention that natural gas from the Permian Basin is not restricted to just these pipelines. At any point along their routes, there are interconnections that enable the fossil fuel to be transferred to a new pipeline. Thus, a more accurate map of natural gas pipelines in America would look something like this. In 2017, the total amount of pipelines the United States had was 1,232,999 miles, or 1.98 million kilometers of length. By comparison, the next biggest country, Russia, has only 101,825 miles, or 163,872 kilometers, of natural gas pipelines in their country. But before we go around bragging about another "we're number one" statistic, we must ask, is this sustainable? For every cubic foot of natural gas burned for fuel, it adds about 0.12 pounds of carbon dioxide emissions into the atmosphere. And there is an enormous amount of climate research that demonstrates that increased amounts of greenhouse gas emissions like carbon dioxide have a direct role in increasing the average temperature of the planet, aka the global warming effect. For 2021, the Permian Basin pipeline operations in West Texas and eastern New Mexico reached an annual high of transporting 16.7 billion cubic feet of natural gas per day. If we assume that the Permian Basin can continue this kind of production every day of the year, then we discover the emission of over 370 million tons of carbon dioxide a year from the Permian Basin alone. Not to mention that Kinder Morgan Energy Partners, Whitewater, Summit Midstream Partners, and EndLink Midstream plan on investing even more money into pipeline constructions that would add another 5 billion cubic feet per day of natural gas transportation to the Permian Basin by 2024. Aside from carbon dioxide emissions, natural gas also releases carbon monoxide, sulfur dioxide, nitrogen oxides, and many other pollutant compounds into the atmosphere. Natural gas is most infamous, however, for its methane emissions that usually occur when the natural gas leaks into the surrounding air instead of getting burned first. Methane is a far stronger greenhouse gas than carbon dioxide, with more than 80 times the warming power during its first 20 years in the atmosphere. In 2019, the Environmental Protection Agency, or EPA, recorded 29% of methane emissions in the United States coming from natural gas operations involving mining, processing, and transportation. While natural gas companies claim to have technology in place to stop the leakage of methane into the atmosphere, a recent study published this year by the American Chemical Society has revealed that an estimated 194 metric tons of methane gas are released every hour in the New Mexican side of the Permian Basin. These studies were conducted using aerial surveys of 26,292 active wells, using specialized cameras that convert infrared images of methane onto a device, thus turning an invisible gas into a visible cloud of emission. The image on the screen is an example of a methane plume from an ONG natural gas site. The white pixels indicate a high probability of excess methane release. Additionally, it is estimated that 9.4%, that's almost a tenth, of all gas production in the Permian Basin is actually methane released into the atmosphere. The same study cites that the lack of economic and regulatory incentives to reduce methane emissions has likely contributed to high methane emissions in the Permian Basin. We hope that this video has helped to visualize the scope of fossil fuel investments in the Permian Basin. It can be an utterly confusing experience to try and make sense of the multitude of activity by megabanks and multinational energy companies in West Texas. Which is why we here at Mesquite Media are dedicated to revealing the truth of what life looks like living near the oil giant of America, the Permian Basin.